All right, welcome to our video here on optimization problems. Okay, so optimization is really taking real life problems. We're going to use calculus to solve them. There's lots and lots of different types of problems. If you kind of read through this paragraph, you can kind of see what they are. A lot of them are geometric, like dimensions of a rectangle with a fixed perimeter, least expensive shape of a cylindrical can, and then start to get into some business stuff like profitable production runs. So optimization is the most used calculus technique in real life. So solving optimization problems, we're actually going to go over two of them. One in this video, I'll do another one in another video. So here are the 5 steps for optimization. I love step 1. Read the problem. So you read the problem, and then you're going to state what's given, what's unknown, and then you're going to draw a picture, okay? And that's usually important for these types of word problems anyway. And then we're going to start to introduce variables. We're going to write an equation, and sometimes there's a bit of a helper equation that's going to help us out, okay? And then you're going to test critical points, and essentially we're going to be using the candidates test because you want to find the possible candidates to see what the largest or the smallest value is depending on what the problem is asking. So let's go ahead and do that out of the way. This problem right here, see if I can fit it on the screen. I can. All right, so let's find the point on a parabola y squared equals 2x that is closest to the point 1, 4. So let's go ahead and draw this. So we did step 1, we read the problem. Okay, let me go ahead and draw this out. So we got an axis like this. Now this is a parabola. Since it's y squared, it's going to be a right-facing parabola. So it's going to look something like this. All right, and then I'm going to mark off the point 1, 4. So again, this is not like the most perfect picture in the world, but here's the point 1, 4. And what I want to do is find some point on the parabola that is closest to that point. So whatever that point is right there. I don't know. So don't look at the graph and just say what the answer is, what you think it is. This is just kind of helping us out. So if we're trying to find something that's closest, now here's a big difference between related rates and optimization. Optimization uses words such as closest or furthest or most. It uses types of words that are kind of going to the extreme. You want the extreme with closest, the extreme furthest, or the greatest volume or least volume. Those are the type of words that we're looking for optimization problems. That's going to tell us that we need to find the derivative and take the candidates test. Okay? So we're looking for something that's the closest. So is there a formula that I know that can help me out with how far away something is? Maybe something that we learned in geometry. Because again, a lot of these are geometry things. You might have learned it beforehand in algebra. Is that the distance formula? So we're going to go ahead and use the distance formula. So what is the distance formula? Well, it's d equals square root of x minus x1 squared plus y minus y1 squared. Okay, so this is the formula that we're going to end up taking the derivative of. So now let's start plugging stuff in from our problem. So d equals, and now this is the point x comma y, and I'm given that point right there, 1, 4. So I'm going to do x minus 1 squared plus y minus 4 squared. All right. Now, I'm not ready to take the derivative yet because I have too many variables. I want to try to get rid of some of these. So I have to find some type of helper equation to help me out get rid of some of these variables. Well, this problem kind of gave you the helper equation right here. Okay, so I can either solve for y to get rid of y's or solve for x to get rid of x's. Now, out of sheer convenience, I think it's easier to solve for x equals, because this y squared is going to produce a square root plus or minus. It's going to give us too much. So I think it's easiest if we say, hey, x is equal to y squared over 2. So I'm going to go ahead and plug that in right now. So I'm going to get d equals square root of, again, y squared over 2. Just plugging that in there for the x minus 1 squared plus y minus 4 squared. And now I'm essentially, with my variables, ready for the calculus step. Now, do I really want to take the derivative at this point right here? Probably not. I'm going to want to clean that up a little bit. Just a little bit of a cleanup, and then the derivative isn't as bad. So let's do some cleaning up here. So d equals square root of, if we expand that all the way out, I'm going to get 1/4 y to the 4th minus y squared plus 1. Just doing some real quick algebra in my head, and I think I got it. Yes. Okay. And then this is going to be plus y squared minus 8y plus 16. Okay. So now cleaning this up just a little bit more, and then I'll be ready for the derivative. 1/4 y to the 4th. My y squareds actually cancel out. Minus 8y plus 17. Whew, doggy. So really haven't done any calculus yet, have I? So recap. What am I trying to do? Finding the closest. I'm using distance here. Plug in the points for my problem. Use my helper equation to get just one variable. Now rewrite it so it's not so terrible. And now I'm ready to take the derivative. So I'm going to take the derivative of this. I'm going to get d prime equals, and now this is going to be a little bit of a chain rule here. So this is actually the same thing, by the way, as 1/4 y to the 4th minus 8y plus 17 all to the 1/2, right? So this is going to give me 1/2. Make sure, yeah, 1/2, 1/4 y to the 4th minus 8y plus 17. So I'm taking the derivative of the outside first times the derivative of now the inside, which is going to give me derivative of the inside is going to be y to the 3rd minus 8. Right? Yeah, that's it. Minus 8. All right, that wasn't that bad. I thought it was going to be worse. So just to make this look a little bit cleaner, I'm going to get y to the 3rd minus 8 all over 2 square root of 1/4 y to the 4 minus 8y plus 17. Okay. So now, not done quite yet, is I need to go ahead and find my critical points and then find my endpoints. So I'm going to talk about the endpoints. Now, in terms of my endpoints, there actually are no endpoints here. Some problems clearly define that it needs to be between two different parts of the interval, but there's nothing saying here that it needs to be, this point needs to be between two other points, if that makes sense. So I don't have an endpoint to plug into. So it's a little bit different of a candidate's test for this problem. I don't have an actual endpoint to plug into. So I just need to find my critical points. So to go ahead and do that, I'm just going to set this equal to 0. So now I just need to go ahead and find, and I just need to find just the top equal to 0, believe it or not. I don't need to do the bottom equal to 0 because that's going to give us something that's undefined, and that's not going to help us out a lot. So I'm just going to set the top equal to 0. So y to the 3rd minus 8 is equal to 0. So solve for y. So y is going to equal, y cubed is going to equal 8. Cube root both sides, y is going to equal 2. So now I need to verify that this is going to be a closest. So it's going to be a minimum. All right, it's just a real quick verification. I'm sorry if I was off the page the entire time. Let me look at that again in the video, make sure I wasn't off the page the entire time. So I just need to verify that 2 indeed is a minimum because I don't have the endpoints. So if I were to plug in like a 1 back into my derivative here, well, the bottom's a square root, so that's always going to produce some type of positive value. So if I plug in a 1, actually I'm going to plug in a 0, it's even easier. So if I plug in a 0, I'm going to get a negative over a positive, so it's negative. If I plug in a number like a 3 on the top, I'm going to get positive. Bottom is also going to stay positive. So if you notice, I'm verifying that, yeah, this indeed is a minimum. So I'm getting y equals 2. Now, Did I answer my actual question? The answer is no, I did not answer my question. I'm finding the point. So I found the y coordinate. So now I need to plug that back all the way back up into here. So plug your y coordinate into the x. So remember, x was equal to y squared over 2, which I'm going to plug in 2 squared over 2, which actually is 2. So my answer for the minimum distance is 2, 2. And there you go. That's it. Now, I do want to show you how to do all of this in the calculator so it's not so bad. Okay? I'm going to go ahead and show you that right now. So, doing the same problem in the calculator, I will use this side. Okay? All you're going to do is type in the original function after I have just one variable. So I'm just going to plug this in right here. Okay? I'm going to plug this in. So square root of parentheses. Now, just to make you aware, calculators don't have y's as a variable, so you're just going to use x. So a calculator is going to say x, but we really know it's going to be a y. So it's going to be, let's make this into a fraction so it matches exactly what I have. So x squared over 2 minus 1 all squared plus x minus 4 all squared. Okay? So that's my distance. Now, what I'm going to do here is I want to find the derivative. Now, the calculator can find the derivative for me, which is totally awesome. So all I'm going to do is hit this alpha button, F2, so alpha window, and then select the derivative, which is choice number 3 right there. So select the derivative, and here we go. We're going to do the derivative with respect to x, and I'm going to just say that that's going to be y1. So if I hit alpha F4, which is alpha trace, it's going to spit out y1, and I'm going to have x equals x. So what's going to end up happening here is this is going to graph for me the what the formula actually looks like and what the derivative looks like too. So if you notice, this calculator is kind of neat where it's going to say blue is the original and red is the derivative. It's going to warn you when it graphs the derivative, it's going to go a wee bit slow. So just make sure do zoom 6. I really don't know if this is going to show up in the picture or not. Oh, there it is. Okay. So if you notice here from the distance, it actually gets the lowest right there. So we can tell that just from that, without even graphing the derivative, is that, hey, we are at the lowest. That's a low point right there. But here's a derivative in red, slowly making its way because it needs to calculate every single pixel's derivative. So, and there we go. Awesome. And I need to wait for it to finish, even though it did what I needed it to do. So remember, I needed this derivative to be equal to 0. So red, I need when red is equal to 0. So boom, red just crossed the 0. So I need to go ahead and find that out. So if I hit second trace, choice number 2 is the 0. So if you set 0, now it's going to start on the blue. I don't want blue. If I hit up and down, I'm going to change my y1 to y2 or whatever you have. If you have y all the way up to y5, it'll keep changing with the up and down. So that's the whole purpose of the up and down. So I'm down on red, need to be on red. That's going to answer its question. What's left bound? Left of the 0. So select any point left of the 0. Like right here is good enough. And then select the right bound. Any right of the 0. That's plenty right of the 0. And then the only reason it says guess is just in case there's multiple zeros inside of your bounds. I only put 1 0 in the bound, so I can just hit enter right off the bat. And boom. It's going to say that the value. Now remember, I typed in x's. So it really should be this really should be the y value. And the calculators aren't so smart. They use lots of programming stuff, so they can't necessarily always get the exact derivative. But 1.999999998, pretty gosh darn close. That clearly rounds to 2. So that's how I got y equals 2 right here. Again, all can be done on your calculator. So just a quick little tutorial of that. One more time, typed in my function with everything plugged in. And then y2, I just typed in my derivative. X equals x, that means it's gonna find the derivative of every single pixel, and then I can go ahead and use that graph to answer me some questions. And that's gonna wrap it up for this video.